All right, in 6.4, we are going to take a look at product to sum and sum to product formulas. So first, let's derive the product to sum formulas. And to do that, we're going to use our sum and difference formulas. Now, I'm only going to do one of these because it is kind of a long written out process, a lot of writing. It's only a few steps, okay? But the other ones can be very easily derived the same way. So what we're actually going to do is take our two cosine formulas, our difference formula and our sum formula. So this was our difference formula for cosine. And then this was my sum formula. Okay, the only difference between them is this one is addition and then this one is subtraction. And what I'm going to do is add these two formulas together. Okay, so I'm going to add everything. Now, when I do that, over here, I'll have cosine of x minus y plus cosine of x plus y. It's not the entirely same thing on the inside, so I can't really combine those right now. And then I'm going to say that equals, well, over here, this term, this whole thing will cancel out because I've got a positive version and a negative version. And then if I'm adding these two together, this would just be 2 cosine of x, cosine of y. All right. So then, if I just divide by 2, or we can think of it as multiplying by 1/2, right? Either way, what I end up with then is 1/2 times the cosine of x minus y plus cosine of x plus y equals cosine of x times the cosine of y. Okay, so this is our first product to sum formula. We can say if I'm multiplying the cosine of some angle times the cosine of a different angle, I can split it up into 2 cosines and add them together using this. All right? So the rest of the formulas can be derived in a very similar way by adding and subtracting different versions of our sum and difference formulas. Okay, but here are what all of those end up looking like that. Okay, if we've got cosine of some angle times cosine of another, or sine of some angle times sine of another, or sine of some angle times cosine of the other, or vice versa, cosine of some angle times sine of the other. All right. So the first thing that we can do with this is a problem like this. Okay, writing sine of some angle times cosine of a different angle as the sum or difference of 2 trig functions. So this is just using my formula. Now, these formulas you will not have to memorize. Okay, for any quiz or a test, I will give these formulas to you. You just have to understand how to use them. Okay, so this first one, sine of some angle times cosine of another. Well, that fits this pattern right here. Okay, so what we can say is sine of 3 theta times cosine of 2 theta is equal to 1/2 times the sine of those 2 angles added together, so 3 theta plus 2 theta, plus the sine of their difference, so 3 theta minus 2 theta. And we can simplify a little bit. Right, so then on the inside here, we'll have sine of 5 theta plus sine of 3 theta minus 2 theta would be 1 theta. And we're essentially done. I could go ahead and distribute that 1/2 through and just say this is 1/2 times the sine of 5 theta plus 1/2 times the sine of 1 theta. And that's it, right? We have successfully written this product as the sum of two trig functions, okay? So we can do this with numerical values, right? We can find the exact value of something like this. Sine of 15 degrees times cosine of 75 degrees. So yet again, this fits this pattern, right? That's just a coincidence. We'll have ones that fit all these different patterns. So we can write this out and say, well, this is going to be equal to 1/2 times the sine of the sum of those angles. So 15 degrees plus 75 degrees. And then plus the sine of their difference. So 15 minus 75 degrees. Okay. So this would be 1/2 times the sine of 90 degrees plus the sine of negative 60 degrees. And then I can actually get these values from the unit circle. Right? So the sine of 90, the y value at 90 degrees is 1. And the y value at negative 60 degrees, right? So negative 60 would be right here. Negative 60 would be the same as 300. So the y value there would be negative square root of 3 over 2. So we can clean this up a little bit. I can get common denominators on the inside here. 1 would just become 2 over 2 plus negative square root of 3 over 2. Combine those on the inside. That would just be 2 minus radical 3 over 2. And then to multiply these fractions together, I would just multiply the denominators. So this would end up being 2 minus radical 3 over 4. Okay, so the exact value of sine of 15 times cosine of 75 is this, 2 minus the square root of 3 over 4. And just a reminder, remember whenever we say something like exact value, that does not mean that you can plug this into the calculator. Right? If you plug this into the calculator, you would get a decimal approximation. But what I'm looking for is the exact answer. Right? This is considered an exact answer. All right. So the next thing that we can look at is sum to product formulas. Okay? So this is just going the other way. If I'm adding two trig functions together, cosine of some variable plus cosine of a different angle, I can rewrite that as a product of two angles. Okay? And we've got 4 different versions of that. Okay? Now, again, I'm just going to go through and verify one version. Okay? We're gonna look at the first one here. Okay? This first one, and I'm going to verify it. I'm just going to take this side of the equation and simplify it to look like this. Okay, so let me write that out here. 2 cosine of x plus y over 2 times the cosine of x minus y over 2. So what I am going to do here, okay, I am going to use the formula for the product of cosines. Okay, so that formula, okay, if we just look back one slide, right, looks like this. Okay? If I'm multiplying 2 cosines together, I can simplify it to look like this. Now, for this problem, that's going to look like this. Okay? I'm going to have 1/2 times the cosine of x plus y over 2 minus x minus y over 2, right? Just the first one minus the second one, plus the cosine of x plus y over 2 plus x minus y over 2, right? Just the first one plus the second one. So we can simplify this then. Obviously out front, 2 times 1/2 is just 1. Then on the inside here, we've got, if I think about combining my like terms on the inside of this cosine, we've got x minus x. Those are going to cancel. And then I've got y minus negative y. So that would be y plus y. So this would become 2y over 2. And then something similar here. If I've got x plus x, that'll be 2x. And then y plus negative y, that'll cancel. Just doing the division on the inside then, 2y over 2 is just y, plus 2x over 2 is just x. Okay, so that is the proof, right, or the verification of this first formula. And to do that, we took this and used our product to sum formula that we just looked at to go backwards and get this. Okay, so I'm only going to do this one. Okay? I'm not going to verify the rest of them for you, but the rest of them would be done in a very similar fashion. Okay, so to use something like this, okay, we can take an expression like this and write it as the product of two trig functions. And we may be able to simplify something. Okay, so if I've got sine of some angle plus sine of a different angle, that's going to fit this version here, okay, this formula here. So I can say this is equal to 2 times the sine of the first angle plus the second angle over 2 times the cosine of the first angle minus the second angle over 2. So now 43 plus 17 is 60. 60 divided by 2 is 30, right? So this just becomes sine of 30. And then here inside of cosine, 43 minus 17 is going to be 33, 28. That's not right. 26, sorry. And then 26 divided by 2 is 13. So I don't know what the cosine of 13 is, but I do know what the sine of 30 is, right? So sine of 30, again, we can use our unit circle. If I go to 30, the sine, the y value there is 1/2. So this would just be 2 times 1/2 times the cosine of 13 degrees. 2 times 1/2 is just 1, so we end up with just the cosine of 13. Now, since this is not an angle on the unit circle, right, it's not something that we know, we can leave our answer as the cosine of 13 degrees. Okay? Don't put that in the calculator and get a decimal approximation. Right? But if we do come across a trig function of an angle that we do know in the unit circle, we want to simplify that. Okay? So let's do another example here, this time with just variables. Right? So this one, cosine of some angle minus cosine of a different angle, fits this one up here. Okay? So we can say this is equal to negative 2 times the sine of the first angle plus the second angle, so 2x plus 4x all over 2, times the sine of their difference. So 2x minus 4x over 2. And we can simplify here. This would be 6x divided by 2 would just be 3x. And then here, 2x minus 4x would be negative 2x. Negative 2x divided by 2 would just be negative x. And we're done. Right? We have written this as a product of two trig functions. And I don't know either of these angles, so I can't really simplify those to numerical values at all. All right? One final example. Let's practice verifying an identity. Okay, so here, in my numerator and denominator, I'm adding trig functions together. Ultimately, this is supposed to just equal the tangent of 5x. So what we can do is use our sum to product formulas. Okay, so the numerator is a sine plus sine, so that's going to be this formula, and then the denominator is a cosine plus a cosine, so that'll be this formula. So in my numerator, I'm going to have 2 times the sine of the first angle plus the second angle, so x plus 9x over 2, times the cosine of their difference, so the first angle minus the second angle over 2. The denominator then will be this guy, so 2 times the cosine of the first angle plus the second angle over 2 times the cosine of their difference, so cosine of the first angle minus the second angle over 2. So we can simplify this, right? These inside of my trig functions, if I've got x plus 9x, that would be 10x. 10x divided by 2 is 5x, so this will be 2 times the sine of 5x times the cosine of, now x minus 9x would be negative 8x, and that divided by 2 would be negative 4x. Similarly, in the denominator, I will have 2 times the cosine of, this would be 5x, times the cosine of negative 4x. So now I see a few things that will cancel. 2 over 2 will cancel and reduce to 1. And then here, these are the same thing. Cosine of negative 4x over cosine of negative 4x. Those will cancel. And I'm just left with sine of 5x over cosine of 5x. Well, we know that sine of some angle over cosine of that same angle, remember, as long as these are exactly the same, sine over cosine is just equal to tangent. So this is just equal to tangent of 5x. And we have used our sum to product formulas to prove this identity. All right, so that is it for this video. The final question is going to pop up asking you what questions you have.